use, and then all of a sudden the problem set is due, and Prayatsa use goes like this, and then it goes like that, and then it goes. So I encourage you strongly to use the forums. If you have a question, almost certainly somebody else has that same question too. So go ahead and post it, and somebody's going to say, man, I'm glad you asked that question. Or you may find they already asked that question, and either Arpan or I or somebody else has already answered that question. So I encourage you to actively use that forum. Whenever you have a sharing system like this, people always say, well, how much exactly are we allowed to share? And you know, it's always a challenge, and here's what I tell students. Full blackboard or whiteboard collaboration is fine. So if you guys want to stand or talk to each other in front of a whiteboard and sketch out how the code works and what you had to do and how you had to change the parameters, that's great. What I want you to do, though, is write your own code. So if you are posting an answer to Piazza, don't post big chunks of code because it's just going to be too tempting for somebody to just take that. Post sort of what you had to do, but I'm asking, if you don't write your own code, you won't understand why it is that certain things make things happen. I every now and then get a complaint from people, why is it that we're implementing things that just exist in libraries? And the real answer is, so when it doesn't work, you'll know why. Because guess what? It often won't work in the library either, or won't work as well, and then you have no understanding of what goes on. So yes, some of what you'll do will say you're not allowed to use MATLAB function A, B, or C. We'll talk about MATLAB in a minute. And it's not just because it's good for your health, right? It's not just like eating spinach. It actually is important for you to develop some understanding as to how these algorithms work. There will be a final exam. It is not designed to be hard. It is simply designed to force you to go back and look at the material and just for a second time get it into your head. And it also allows us to ask some questions about stuff that didn't show up on the problem sets. Normally when I give the exam here, it's a 3-hour slot and it takes people an hour. But it just basically covers the base material. The grading, current rubric is that 85% of the grade is based upon the problem sets, and which means 15% of the grade is based upon the final, and the other 10% of the grade is based upon how I feel. All right, so the last thing we have to talk about are the logistics of how you actually do the work. And essentially, there's going to be 2 places that you're going to be doing the doing. Well, 3. First, there are these Arpan quizzes where you just have to click on the dots or fill in the things, and usually those are just going to be making sure that you're not asleep while watching the videos. The real work's going to come in terms of doing some computer vision work. First, whenever we introduce certain image processing or computer vision types of new algorithms or methods, as often as we can, we'll produce some embedded programming exercises, which you can actually use while you're doing the videos and work within them. And in particular, there may be a function that MATLAB already implements, and so you will play with the function in the embedded system that you can just use, so you might come to understand the different, say, the effect of the parameters. But then when we get to the problem sets, you'll actually be writing some of these functions for your own. So let's talk about your own software environments. Most of the examples that I will describe and talk about come from using MATLAB. I use MATLAB normally when I teach here. I use the base MATLAB plus what's called the image processing toolbox. By the way, there is a computer vision toolbox also for MATLAB. I don't make use of that in this course. It has some of the more advanced things. For what we do, we just need MATLAB and the image processing toolbox. By the way, for any of you that are actual students with a student ID or academic affiliation, there is a student version of MATLAB, which costs less than most computer vision textbooks. If you go to a company and you have to buy MATLAB, it is a relatively significant piece of software to acquire. The fact that you as a student can get MATLAB as at a student discount, and by the way, the license never expires, you just get to use it, I highly recommend you go out and do that. And no, MathWorks has not paid me anything to say that. Really, honestly, I wouldn't kid you. But if you don't want to do that, there is an open source version of something called Octave. And Octave is a open source sort of equivalent of MATLAB. And there's also image processing toolbox equivalent available for Octave. Arpan will give you a little more detail about exactly how to get that and in order to get that installed. But that's the examples that's the sort of system that I'll be using as example. For some of you, you might rather do this using Python and OpenCV. OpenCV is something that originally came out of Intel, took a winding path through Willow Garage for a while, is now part of, I think, the open source robotics, something. It's moved into a not-for-profit that's sustaining it. OpenCV has really enabled people to do a lot of image manipulation stuff in a robust way from either Python or C++. When we give out the problem sets, if there's something special that you need to know about how to do it in Python/OpenCV versus MATLAB, we'll describe both of them. And you can use either one of those programming environments. MATLAB tends to make things a little easier, things like plotting and clicking on images and seeing what's going on. Python and OpenCV is a little more connected to what you might actually have to do out there in the job world to actually produce computer vision code.
If you choose to use MATLAB for this course, you will need base MATLAB along with the image processing toolbox. Head over to the MathWorks website and look for the latest release. Click Buy Online to see pricing options. We recommend getting a student edition. You can either choose the MATLAB and Simulink Student Suite, which includes the image processing toolbox, or you can choose the base MATLAB version and the image processing toolbox separately. Note that you may need MATLAB or specific toolboxes for other courses, so choose wisely. Your institution may also have a volume licensing agreement with MathWorks, so find that out before you download it for yourself. Once you have MATLAB installed, try out a few simple commands. The command window is connected to an interpreter. This is where you will spend most of your time. You can type in arithmetic expressions that are evaluated on the spot. You can also create variables. Note how it printed out the value of the variable here. If you want to suppress that, use a semicolon at the end. You can also create vectors and matrices and run operations on them. You might have noticed this workspace being updated. It lists all the variables currently in memory and a value assigned to them. There is also a file browser that lists the files in the current folder. MATLAB has built-in functionality to read images. We will use the imread command. Note that you can use tab completion to make your life easier. Tab completion also works with file names in the current directory. You can display an image using imshow. The image processing toolbox contains several useful commands for working with images. One of these is RGB to gray. It converts a red-green-blue colored image into a grayscale or monochrome image. The MATLAB website provides great resources to help you get started, including code examples, webinars, and extensive documentation. Octave is a free and open source language for numerical and scientific computing. It is mostly syntax and feature compatible with MATLAB. You can download it from the GNU Octave website. Follow the instructions for your corresponding system. Linux is probably the easiest, and Windows is a bit of a pain. I'm on an OS X machine here. There is a binary installer for OS X, but I've had problems with it later on when trying to install packages. So I prefer the Homebrew route. If you don't have Homebrew set up already, first install Xcode. Then open up a terminal and use the Xcode select command to install command line tools. Now you can install Homebrew. You will also need a LaTeX distribution like MacTeX. This may take a while to download. Once you have Xcode, its command line tools, Homebrew, and MacTeX installed, continue with the instructions on the wiki. Once you have Octave installed and it's in your path, you should be able to run it by simply typing Octave. This is the Octave interpreter, similar to the MATLAB command window. You can type arithmetic expressions, create variables, and even work with vectors and matrices. To suppress the result of an expression showing up in the output, use a semicolon at the end. You can type exit to come out of the interpreter. You can also run Octave in GUI mode. Note that this might still be an experimental feature and tends to break very easily. You can carry out the same operations here as the console version. In addition, you have a workspace which lists the variables currently in memory, and a file browser showing contents of the current directory. As in MATLAB, you can read images using the imread command and display them using imshow. The base installation of Octave does not include any additional packages. To install a package, we need to use the pkg install command. The -forge option pulls packages from the online Octave Forge repository. Octave Forge contains an extensive collection of packages. We are interested in the image package. Notice that this package has some dependencies. We can install the image package along with all its dependencies, namely general, control, and signal, in a single command. Once installed, they should show up in the list of packages. Now you can load the image package by typing pkg load image, and then use functions from it like RGB to gray. It converts a color RGB image into a grayscale or monochrome image. For more information on the image package, check out its Octave Forge page. There is an extensive function reference that you will need to use frequently. The Octave Wiki is very useful as well. It has installation instructions for a number of platforms, as well as tutorials and examples to help you get started. Play around with these to become more familiar with the Octave environment.
To help inform us a little bit, what do you expect to learn from this course? Put it in the text box here. We'll collect them all. And as we go through them, it'll help inform just a little bit in terms of how we think about the answers to the questions and the discussions that we have on the forum. All right, so look, that ends the motivation and sort of what computer vision is and why you might do it and how we're going to do it in this class. Arpan, you have anything else you want to add?
Yeah, I just hope that you're excited about the course by now. To make sure that you don't listen to the entire course like a podcast, I'm going to step in with some annoying little quizzes.
Annoying, huh?
Yes.
Oh, okay.
They will find out.
Okay. Arpan's been practicing all his life about how to be annoying. That's what his mother told me. So I think he's got it down. But anyway, it's time to get started. It's a bit of work, but I think if you do it, you'll learn a lot of computer vision. So let's strap ourselves in and just get going. All right. Well, welcome to Computer Vision. Hopefully from the introduction you feel inspired to charge through here. And what we're going to do is we're going to start off easy and frankly we'll get kind of hard towards the end, which is okay because by the time you get there you'll be ready to do that. So today we're going to talk about images. Now most of you think about images as something you see on a screen, or if you're old school like me, something that's actually printed in a magazine. It's something you can look at. So here's an image of an old, and I think now expired comedian who's therefore cannot sue me. That's Phyllis Diller, by the way, in case you remember. And by the way, we're going to start with black and white because black and white just makes everything easier because it's just a single channel. We'll do color on and off, but pretty much everything that we do for black and white, you do for color, holds for black and white, and it's just easier. So when I show this to you, you actually think of it as a picture, something to look at. But what it actually is a function. In fact, we can just call it a function of I of xy, all right, where the I has something to do with the image intensity. So if I think of this as a function, then I can just plot this as a surface. And in MATLAB, it makes this incredibly easy. And if I did, it would look something like this, okay? Now, this is the exact same function. But instead of showing you as a picture, sort of straight on, and by the way MATLAB does it's really cool, the higher the thing is, it also makes it brighter so you can see. So if you take a look at like the checker pattern on that awful shirt she was wearing, right? So the bright spots are here and the dark spots are down there, okay? That function is the same function as the image that I was showing you before. Computer vision, and especially image processing, and we'll be talking mostly about the image processing side of computer vision today in the next few, are about taking these functions and computing something from them. Often, we're just going to compute another image-like function. So images in, images out. And sometimes we'll be getting some sorts of information. So here's a very simple example. Suppose I took that previous function and I just smoothed it. All right, so now you see I have the same surface I had before, but it's now, it blends smoother, and the peaks and the valleys of that shirt are much smoother. They're not as steep as they were before. Okay? So that's the